All right, Gavin, it's been a few days for these students since they last had class, presumably for you also. They had field day Friday, and then, of course, the weekend. So we're reviewing over radicals, and we said in order to add radicals class, the radicals have to be similar, meaning two things. Same index, same radicand. Good. We know that considering we have a test coming up in 2 more lessons. Okay, so this is lesson 165, I believe it is. 166, 167 will be our test. So multiplying radicals, they don't have to be similar, right? To multiply radicals, all you have to have is the same. Did I mention we have a test coming up in just a couple of lessons? The same index. Class, what has to be the same in order to multiply? Same index. Okay, now I did show you one problem that you might have to do in Algebra 2, for instance, where you might not have the same index. But this is Algebra 1. Okay, we have pity on your poor souls. So, you're already going to have same indices here. And so really just multiply. We'll multiply the coefficients, multiply the radicands. And when do you reduce in a multiplication problem, generally speaking? At the end. You don't have to reduce at the beginning, you reduce at the end. Now, in an addition problem, generally your radicals aren't going to be similar, so they're not going to look similar. You're going to have to reduce those first, then add. But in multiplication, you can just multiply and then worry about the reducing. Got 5 classwork problems for you, and then we'll take a look at your homework. So multiply the coefficients if there are any, multiply the radicands, and then reduce if possible. Finished. and check your answers if you would. The first one, cube root of 28, you can't do anything with it. There's no cubes. 8, no. 27, certainly not. And definitely not anything bigger, so can't simplify it, leave it as cube root of 28. On the next one, multiply to get the 5th root of 96. Now, we don't do a whole lot with 5th roots, but we have memorized that 2 to the 5th is 32. And sure enough, there's a 32 in there, 2 times the 5th root of 3. How many good on the first 2? Questions? On the next one here, 12 times the square root of 50, factor to 25 times 2 plus 5, get 60 times the square root of 2. On the next one, multiply to get 2 times the 4th root of 16, and wait a second, that's rational. We don't even need to reduce that, just take the root, it's 2, times the other 2 gives us 4. How many good on the 3rd and 4th? Okay, question. And then on the last one, remember when you multiply like bases, you add the exponents. That's what we're doing here. That's how we get the a to the 5th and the b to the 7th. And of course, 6 times 3 is 18. Of course, we'll factor it in 9 times 2 to pull out a 3, leave a 2. And of course, the 2 index goes into the 5 exponent twice with 1 left, goes into the 7 3 times with 1 left. How many got the last problem correct? All right, question on that one. Questions at all on the classwork with multiplying radicals? All right, let's go ahead and take a look at your homework now. Page 292 is where we'll start. I want to look at that word problem first, and then we'll get to the other part of the homework where we worked on multiplying binomials involving radicals. There was some FOIL. There were some binomial squares. Square the first, square the last, multiply and double. There were some sums and differences that had to be taken care of. Square the first, square the last, put a minus sign between them. Also had a couple of problems where we're just distributing. But we'll look at all that in just a moment. We're going to start on page 292, word problem 4. Read that for us, if you would, Noah.
Max grocery has 25 employees. The average daily wage for a teen is $52, and the average daily wage for an adult is $90. If the daily payroll is $1,984, how many teens and how many adults are employed?
All right, so obviously the adults get paid more than the teenagers. Why might that be, Noah? They just like adults better?
Adults have other stuff they need to take care of.
Okay, adults probably take care of more responsibilities, right? There's certain things you can't make a teenager do because of child labor laws. Okay, and there are things you can make the adults do. So adults probably do maybe more responsibilities. What's another practical reason why adults would get paid so much more? Almost double, right? Anyone? Where do teenagers spend most of their day? School, which means they're not working. But where can the adults spend most of their day? Max grocery. Yeah. So since the adults can work more hours, obviously it makes sense the adult will get paid more. So they may even be paid the same wage rate, possibly, but the adults are making more money. How did you set up your system of equations here, Noah? Well, first of all, what are the unknowns? Teens and adults, right? And that's a good place to start. It's just by identifying the unknowns. And of course, we'll represent these as X and Y, okay? What was your first equation?
52X plus 90 equals 1,984.
In other words, we take the money that each teen is being paid times the number of teens, plus the money each adult is being paid on average times the number of adults, and that should equal the total money being paid out. Money plus money equals money. What was your other equation?
X plus Y equals 25.
All right, number plus number equals number. 25 people work in there. Some are teens, some are adults. X plus Y equals 25. How many had this system of equations? Good. Now notice we didn't set up the usual chart. Number of each, money to each, total money. And frankly, when you're working with a system, we've seen so many of these, we probably don't need that chart to figure this out. Noah, what do we do now?
Multiply 90 in the bottom.
Good, multiply a 90 through the bottom. And when we multiply, of course, 90 times x just comes out 90x, 90y. What about 90 times the 25? I'm sorry? Somebody help him? 90 times 25? What'd you get? Assuming we did the same thing? Or did y'all multiply by the 52? Oh, 90 is an easier number to multiply. 52 is annoying. Why would you do that? Did you also do 52, Maddie? I think it's 2,225, or 2,250 if I'm not mistaken. 25 times 90, 5, carry the 4, yeah, 2,250. Should have been what we got. We multiplied 90 times 25. All right, at this point, Noah, what do we need to do?
Make the top negative.
I would change the signs at the top. Now, you would have multiplied by the 52. You would have changed the signs where you multiplied the 52, which might have been the top, I don't know. But you would have changed the signs there. And so that would have gotten you not a, what is that, a 38x. You would have gotten 38y, I believe. And you would not get the number that Noah's about to get. Let's see, let's borrow here 10 minus 4, 14 minus 8, and 11 minus 9, 2, and 1 minus 1, of course, is 0. How many times do you think 38 is going into 266? It's got to be a whole number, right? Because otherwise, we have a partial number of teenagers, which is sort of strange. This is almost a 4. How many times would an almost 4 go into 26? 6, 7. Yeah, let's go with 7. Sure enough, times 8 is 56. Carry the 5. There's our 26. So yeah, 7 teenagers. And remember, 25 employees. How many adults? 18. And did you all get y is 18, and then you went back and got the x is 7 by the subtraction? All right, good. And these should have been our answers here. They got it. Noah, a little bit of a multiplication error there. Questions? All right. Let's go and take a look at page 288 now. Page 288. And let's take a look at exercises 28 to 52. 28 to 52. And you were doing every other even, so all the multiples of 4. All right, for your homework. Okay, there it is. I see it now. All right. Bueno and bueno also. Good. All right, looking at number 28 here. All we have to do, Maddie, is distribute the 4 to get. Right, 4 times 9, 36. We try to multiply 4 times a negative square root of 7. One's rational, one's not. They don't mix. Just negative 4 square root of 7. How many have that answer on 28? Did you have the square root of 28? What did you have?
Like 42.
Oh.
Times the square root of 7.
Oh, yeah. All right, let's take a look at number 32. We've got a negative 3 times the square root of 7 being distributed to a w plus the square root of 14. This one comes out kind of strange here. Bracken, the first distribution is really not too bad, but how would we write that product? Perfect. Remember, the sign always goes first, then number, then letters, but the radical is always last. Great job, Bracken, sticking the W in between. And then when we initially multiply here, we're going to multiply the coefficients, then we're going to multiply the radicands to get initially. This is number 32. Help? 98. Okay. But somehow, Bracken, it looks like we could reduce that 98. Anyone? What squares in 98? We've seen this number several times. So if we're paying attention and engaging our brains, we should remember this one. 49 times 2. Remember, 50 times 2 is 100. So 2 less would be 49 times 2. So Brecken, back to you. Out of the 49, we take its square root. Multiply that by the 3 we had. What's our final answer? There we go. And of course, we'll keep the negative 3w times the square root of 7. Anyone have this answer? How many left it right here with the 98? Make sure we reduce at the end. Number 36, we have a binomial, and we need to square it. What are those 3 steps to squaring a binomial? Noah? Multiply double. Square the first, square the last, multiply double. Because remember, when you square a binomial, you get a... Ooh, class help. And this is going to be on the exam, by the way. Perfect square trinomial, which is why we remember 3 terms. Square the first, square the last, multiply, and double. So when we square the first, no, that's easy. There we go. When we square the last, we need to remember that when we square, we always get what sign? And then when we square the radical, we're squaring 2 things. We're squaring the coefficient, and we're squaring the square root. We get the... Class, when we square a square root, we get the radicand, which is in this case, Noah, 5y. And then we need to come back to multiply and double. Now remember, double means there's a little times 2 sitting out here, if you want to think of it that way. Sine, number, two times 2 times 7 equals, class, 20. Okay, there it is, 28. All right, letters, well, there's only one letter, and that's the y. And then we also need to keep the radical. There's no other radicals to multiply the square root of 5y by, so we'll keep that. Last thing is to go ahead and simplify a little bit right here. Anybody? 245y, Maddie to the rescue. All right, and so there, if we put our radical term at the end, is our answer. Maddie, you had it, it sounds like? All right, no, not so much. Brecken? Not so much. Okay, we have a test coming up in a couple of days. Questions? All right, let's move on. Number 40, and Maddie, let's come to you, though you kind of just did Noah's problem for, I'm just kidding, it wasn't quite that bad. All right, what is this thing, Maddie? Sum and difference. We need to do what 3 things to multiply sum and difference? Square the first. There we go, square the first, square the last, put a minus sign between. When we square the first, we get? When we square the last, we get, and we put a, and then we simplify to get. There we go. How many got 1? Brecken questions. You forgot 2 minus 1? You had 3? Oh, you left it as 2 minus 1. All right. Number 44. Brecken, we had 5 negative square root of 3 being multiplied by a 10 plus 2 times the square root of 3. And we notice that our first terms are just plain old integers. And we notice that our second term in each case is a square root of 3. That makes these binomials, class, similar binomials. And how do we multiply similar binomials, Brecken? FOIL, what does FOIL stand for? Yeah, first, outer, inner, last. So, Brecken, when you multiplied your first, when you multiplied your outer, when you multiply the inner, yeah, make sure we pay attention to signs, and then our last. Negative 2 times the square root of 9. Of course, we know the square root of 9 is just 3, so that's really negative 2 times 3, or in other words, And we can do a little simplification here. But notice that our firsts are just integers. And we notice our outer and inner can combine, or really they can. And so our answer is just 44. How many had 44? Four number 44. No, nobody had 44. Did we get maybe this step and just forgot to simplify? Okay, questions? Did you notice that if you took a 2 out of this, this is 5 plus square root of 3? It's a sum and difference. They just put a 2 through one of the two things, so hence the outer inner still cancels. All right, questions on 44 being 44? All right, let's take a look at 48. And once again, Noah, we have what in number 48? Two similar binomials. So once again, we have to. Now, before I erase this, let me point something out, class. If you can only figure out or really master one of these, make it FOIL. Because what could you do with a binomial squared? Write it twice in FOIL. What could you do with a sum and difference? FOIL. Is it faster to square the first square last, multiply and double? Yeah, I think so. Is it faster to square the first square last, put a minus sign between them? Absolutely. But couldn't you FOIL in each case? So, I mean, at least figure out FOIL, and you can use that anytime you're dealing with binomials involving radicals, even if you forgot the other shortcuts that we've learned. Noah, back to you for this FOIL problem. Let's multiply the first. Outer. All right, inner. And last. All right, and of course, no, we know the square root of 36z squared is just 6z. Realize you multiply a square root of 6z times another square root of 6z. That's essentially squaring the square root. So we get the radicand, but it's not wrong to start with the 36z squared. Just knows, well, that's going to be 6z, which means I can multiply the negative 10 times the 6z to get negative 60z. Now this time, my first and last don't combine because they're not just plain old integers, right? That happens to have a letter with it. But I can still combine the outer inner Noah. There we go. So we can get a 16 negative 60z minus 36 times the square root of 6z. Did anyone have this answer on number 48? All right, when did we do this homework? Did we do it last night or this morning? Or did we do it Thursday night or Thursday in study hall? When did we do the homework? Yesterday. Okay, that explains a lot. You just need to remember doing it. All right? Saturday. Okay. Math and grammar, those two, do them same day. That's your first thing to do in study hall. Knock out your math and your grammar in study hall. Okay? Other stuff, you can read history anytime. You don't have to remember anything to read history. You don't have to, or health. You don't have to remember anything to read over your physical science, right? You don't have to remember anything to do your literature reading. But you do have to remember stuff to do grammar and math. Do those first. All right, let's move on to 52. Where we have y minus y times the cube root of 8y. And we're multiplying that by 6y plus y times the cube root of y. You might be asking yourself, why? But anyway, we come to Maddie for the answer to the question of why. And Maddie, what do we do? Yeah, FOIL again. Now, it's not going to maybe work out perfectly here because they're not quite similar radicals, or are they, Maddie? Are these similar radicals? If you took the cube root of 8 at the beginning, that would give you a 2. And now you would just have cube roots of y in both places. We don't have to do that, but technically you could make these similar radicals, I suppose. Let's assume we didn't think to do that, and let's just FOIL. First, outer, inner, and last. All right, and really not a whole lot combines here initially, though I notice once again I do have a cube root of 8 in each of these cases, and both times the 8 I can take the cube root to get. So both times I should do that. Let's simplify it down. Now what do we have? And in our 1, 2, 3, 4 terms, 2 of them are like to each other. Right, the outer inner, so what do we get when we simplify a y squared cube root of y and a negative 12y squared cube root of y? And of course we'll keep the 6y squared there at the beginning. We'll also keep the negative 2y squared times the cube root of y squared. And there is our final answer. Anyone else get this answer? Maddie, did you have that answer? Okay, good. Questions on this? Let's do a little bit more practice. Turn back to page 292. Turn back to page 292 and do numbers 13 to 16. Page 292, numbers 13 through 16, practicing with these binomials with radicals in them. the last two, 15 and 16. If you feel more comfortable with FOIL than square the first, square the last, multiply and double, FOIL it. Just write it out twice. Check your answers to 13 and 14 if you would please. Check your answers to the first two. Now these are not similar binomials, okay? So FOIL, again in the sense of the outer inner combining, does not work. But remember, FOIL really is just double distribution anyway. So that's really all I did. You distribute the square root of 3, then you distribute the square root of 2, and that happens to be FOIL, okay? How many got 13 and 14 correct? You got both of them right. Reckon's checking. Good, all right. So then, how many feel like maybe it's just easier to FOIL instead of try to square the first, square the last, multiply and double? Anyone feel that way? How many feel like, nah, square the first, square the last, multiply and double is easy enough? Brecken doesn't know what he thinks. All right, Brecken, let's try square the first, square the last, multiply and double and see how it goes. Square the first. Square the last. Which is, of course, 20. What sign? Always positive because you're squaring. Then multiply and double. All right. So multiply and double means you multiply all the numbers first. 4, because that includes the double, right? And then you multiply the radicals. Square root of 15. If there were any letters, you'd do that too. And of course, the sign is positive. As opposed to, Brecken, square root of 3 plus 2 square root of 5. Square root of 3 plus 2 square root of 5. Your first is the square root of 9, which becomes 3. Your outer is a 2 square root of 15. Your inner is a 2 square root of 15, and your last is a 4 times the square root of 25, which is 5, which is 20. Okay? We end up at the same point, notice. There's your 4 square root of 15. Takes a little bit longer, but it may be easier. Does that make sense? It may take a little longer to do, but it may take less concentration, maybe. We can finally end by adding the 3 and the 20 together to get. And that would be my answer. How many had this on 15? All right, Noah question. Noah, help me with the last one. Do you want to square the first, square the last, multiply and double, or do you want to FOIL? All right, square the first. Good, 4 times 3, which becomes 12. Square the last.
16.
What sign? Always positive. And then multiply and double.
-32.
Ooh, 2 times 2 times 4. Good. The square root of 3 had nothing to multiply by. Here, the square root of 3 had a square root of 5. Here, the square root of 3 has nothing else, so we just kind of keep it. And again, no letters in there. Last of all, no, we can combine the 12 and 16. And there's our answer for number 16. How many had that for 16? All right, questions on this? All right, clear desk, except for a clean sheet of paper and a pencil. Let's go ahead and wrap up this section on multiplying radicals. Tomorrow we will be reviewing for the test, which will be Wednesday. Gavin, we're going to end the video here in just a moment once we start the quiz. However, I will be writing the homework on the chalkboard. I'll leave the video up for just a moment. If you want to just pause the video, go ahead and take the quiz, and then you can copy down the homework. That's what the students will be doing as well. First and last name at the top of your paper. First and last name at the top of the paper along with today's date, which is 5/10/21. 5/10/21. And this is quiz 34. Quiz 34. First four problems are simply true or false, right? The whole word true or the whole word false. And then for numbers 5 through 13, you are multiplying those radicals. Make sure you simplify as much as possible. All right, Gavin, I'm going to put the homework on the board, but students, you may begin.